6S plugin. It says it does 6S. Seems like it wasn't lying. So I don't really know why I have this thing, but now that I do, I'm going to use it to talk about a couple other concepts. Light versus heavy, 3-inch quads, and voltage. When do you need higher voltage, and why do you need higher voltage with respect to flight time and whatnot? But let's first talk about this particular quad. So this is the Eachine Wizard X140, I don't even know what it's called, but this is a 3-inch quad from Eachine. I'm going to just jump to the end and tell you that I definitely do not recommend this thing. I actually think this is one of the most poorly set up, ready to fly products that I've ever used for a number of reasons, which I'm going to point out in a second. But it is a 3-inch quad. It'll weigh about 250 grams with whatever 6S battery you put on there, all up weight, ready to fly. And so the best part about this thing are the motors. So these are 1507 2500 kV motors, and that's the first major confusion, is that they're 2500 kV, and this is supposed to be a 6S quad. If it's going to be a 6S quad, it really should have 2700 kV motors, because that's more of a 6S kV range with respect to what we run 4S on 3-inch quads with, whatever it is. I actually don't think they're actually 2500. I believe these are probably closer to 2700 kV than 2500, given the performance I was getting. The 1507 size is a very interesting size. Traditionally, we have run 1407, 1408s on 3-inch, on heavy 3-inch quads, and those have been really great. However, recently we've had 1606s and a couple of other slightly wider motors that are a little bit shorter, and they tend to manage the 3-inch prop a lot better than the 14 size motor. A lot of pilots say that the 16 or 15 size motors just generally feel like they have a lot more control, a lot more power, a lot more everything. I personally feel that the 7 height on these motors, or 8 height on these motors, may be a little bit much. And what I found in these micro motors very recently, actually, is that the higher motors just tend to suck a lot more amps and not really give you a lot more performance for those amps. You do get a lot more efficiency with a wider motor. However, it does kind of throw the throttle curve off, and so you really do have to balance things. For now, I think that this 1507 size is a great size for a 3-inch. I think that 1604 is going to be a really great size for 3-inch if somebody decides to make a 1604. But anyways, let's take a look at this motor. This is a 1507 motor. I think that RC and Power are making the motors for Eachine, and that's because the general structure of the motor, like the bell housing, the top of the bell housing going over the entire magnetic flux ring, as you can see underneath, if I can get this damn thing focused. As you can see here, there's a lip around the edge that you can see that the whole bell housing goes over the flux ring, and that's how RC Power has been making a lot of the recent motors. At the same time, you'll see here that the air gap between the magnets and the stator is just impossibly tight on these motors, just crazy tight. And it's one of the things that I've been really impressed with this motor, as well as the other 2306 version of these purple motors that Eachine has made. They're really shockingly powerful and good motors for Eachine. I mean, I wouldn't expect Eachine to be making such great products. However, they do make some that are really, really great, like the VTX03, which in my opinion is the best low-cost VTX still to this day, and it's years old at this point. Anyways, the motors are the best part. The props are the Cyclone T3056, also very good props for heavy 3-inch quads. I'll get to the light 3-inch quads in a minute, but heavy 3-inch quads. The camera they're using is the Foxeer Aero, which is totally fine as a CCD camera, which is great. Not the best, but at least not the best in my opinion, but great. It is a great camera. The quad, the frame is a little bit of a sore spot. I broke an arm. One crashed because I decided to desync and I broke an arm. I'm gonna bend it. Holy moly, that is flexible. Alright, I'm just gonna keep flying it with this broken arm. At least I get clearance on that motor now. Oh my god, I broke 2 arms. Holy, wow. It's like, okay, I'm gonna attempt to fly it again. I'll talk about that in a minute. The ESC clearly, as you saw in the flight video, is not reliable, and it does 4S fine as well as 6S fine. However, it desyncs and falls out of the sky. It has a board back here that has a beeper on it as well as a bunch of LEDs, and manages the EL, or this string of LED light, LED-ish light that goes around EL lighting around the board. I'll get to that in a second. Anyways, so yeah, there's an entire board in there that you really don't need. It doesn't really add much to the weight. However, there's really nowhere to put your receiver, so I just had my receiver taped to the bottom here. And that seems to work out fine. However, I wouldn't really recommend that. One of the major issues with the frame, which I'll get to in a second, is the frame has been cut very poorly. As you can see, going down the arms, the carbon is cross-hatched. So that means that the arms are very, very, very flimsy. Very flimsy. And I'll show you the flex on my, this is a 2mm arm. 2mm arm takes a lot more pressure to flex this 2mm arm than it does this 3mm arm. It flexes like it's made of cardboard, literally like it's made, it feels like it's made of cardboard, and that's because the cross hatching is just improperly, it's just, the frame is just improperly cut. However, and as you saw in the first crash, I broke both these arms. The crash was due to a desync, and it just fell and broke two arms, which I wouldn't expect on arms that are so short. In addition to that, the general frame structure, as you can see in the front here, is that these two plates that hold the camera, they jut down below the bottom plate, and that's so that they can get the top plate lower down on this whole frame, so that they could bring the battery down, because it seems to be a popular thing to do. However, and also the camera needs to jut out from the bottom as well. However, as you can tell, there's only these two tiny little spars on either side that actually hold the whole front of the frame together. And this is something that Hyperlow has done, and then X-Hover has been inspired by and done on the Stingy frame. And the way Hyperlow did it is that he actually realized that it's a potential failure point, and he did beef it up a little bit, and it has been fine. However, X-Hover didn't really pay attention to that, and I even told them that it's going to break there, and they shipped it anyway. So they said, no, we haven't had any failures, and they had a lot of people that broke them, so they started sending out new bottom plates to people, as well as reinforcement plates, so they just kept adding more weight to whatever. This is not a good design concept. It's not really great. On top of that, you have this EL lighting strip that has a trough now cut through the frame, making it even thinner, as well as thinner on the entire arm structure that is already poorly. Just not a good frame. Not a good frame design at all. Also, to add insult to injury, I don't know if anybody actually even flies the darn thing before they sell it, because when you put the battery on top, you can't, there isn't enough clearance between the prop and just the strap even, let alone the battery, to actually spin. Like it's actually a challenge to get the battery on top and still have the prop's ability to actually spin. So clearly somebody wasn't paying attention when they put this thing together or designed the frame, because it needs to be like 3 millimeters longer diagonally at least, just to clear, almost, not even clear, just to almost clear. Anyways, the motors are the best part. The rest of it's not very good, and I really wouldn't recommend it. But now let's jump to the difference between heavy 3-inch and light 3-inch. So this is another frame that I have, another micro design that I had tested before. This one has the Cat X turtle in there, and unfortunately the split cameras don't really have enough vertical field of view to be used as a really nice FPV cam. They do work fine, but if you do want to fly a whole bunch of different ways, it's a little bit of a struggle. So that's why I've kind of been testing and taking things apart. Anyways, this will have an all-up weight of around 135, 140 grams. It's a very light frame, very light build. It's got a 16 by 16 stack in the back, and it performed okay. And that's going to be one of the first differences I explained between light 3-inch and heavy 3-inch. So heavy 3-inch quads have a lot of power. This thing actually has a ton of power, and that's why I strapped a GoPro to it to fly it around, because I'm like, hey, it's got so much power, it's going to be fine. On top of that, it's 6S, so it should be no problem carrying a GoPro. And in fact, it really wasn't much of a problem to carry a GoPro. It did carry it totally fine if it wasn't like desyncing out of the sky and just falling to the ground. It did carry it fine. And this thing really has no problems with control and everything. It flies totally fine. It's just really the structure of everything, the way it's set up, that's just very poorly done. On light 3-inch or just light quads in general, you don't have that same kind of power. You just don't have a ton of power to work with. So the weight distribution of things really does impact a lot. And I talked about this in a previous video and other videos before as well. Having this long fuselage was a big issue for this frame, and I had the previous GEP-RC 1206 motors on there. While those motors do have a lot of power, it's not nearly as much as a 1507 motor. So like a real 1507 with really beefy like it's just not the same kind of power. So it did have to expend a lot, I'm guessing at least, this is my theory, my concept at this point, it did have to expend a lot of energy maintaining the attitude of the quad in the sky before it actually started executing the maneuvers and inputs that I gave it. So it did make it feel very loose in the sky, whereas this thing with no GoPro and nothing on board, it feels really nice and tight in the sky. Like it's got so much power, it doesn't care that there's more weight on the front to back axis. It can perform great. However, there's also a big difference between this and this. While this little light thing is very quiet and very nimble, if you know, not this layout, but with a layout that's more reasonable and actually flies well, very nimble, very light, very quiet, very docile to the point that people aren't threatened by it. It doesn't make much noise. It's like really safer, very, very much safe. It's not quite as fast as this one either, but it's also a lot of fun to fly because you have so much throttle authority because it weighs so little, and you don't need a lot of power when it weighs so little as well. This thing, when you fly it, I mean, it sounds like a 5-inch. It doesn't sound like a little tiny quad. I would not fly this thing around anybody. I wouldn't fly it in a park where there are any people because it's no safer than a 5-inch quad. I mean, it goes probably 80 miles per hour, 70, 80 miles per hour. It's fast. It's not slow. So why would I fly this over a 5-inch? That's the struggle that I see in these light 3-inch, or not light, these heavy 3-inch quads. Sure, they're powerful, sure, they're fast, sure, they have all those things, but why would I care to fly a 3-inch when I can just fly a 5-inch? What I see the heavy 3-inch class as most useful for is for beginners. I think it's one of the very best beginner sizes because not this particular frame, but if you have a 3-inch frame that is modular, it's much less likely to break than a 5-inch with much longer arms and much more weight, because 250 grams for a heavy 3-inch is totally reasonable, is totally doable, not even a challenge, and you have just heaps of performance, and it really feels very similar to a 5-inch. The only real difference between this and a 5-inch is that coming out of dives and doing various moves, you might have to really hammer the throttle to get it out a little bit, and it is a little bit revvy, like you kind of hit a point in your throttle range where it sort of takes off on you a little bit, but that's really not that drastic. It really does feel a lot like a 5-inch. Really, really, truly does. Anyways, I'm going to stop there about the difference between heavy and light. I personally prefer the light stuff because it's a different class of quad. It performs differently. It allows me to fly in different areas. It's just a totally different scenario. That's why I've been kind of researching in this light class lately, because I just think it's not more fun, just more reasonable for all scenarios. Now let's get to voltage. Why on earth did they make this thing 6S? So here's the other reason why I think this is a very poorly set up product. They are expecting people to buy this thing and then buy 6S batteries to go with. Like, you can't use the batteries you already have, and it's already not like a beginner product. It's definitely not a beginner product. You do have to set it up and know what you're doing to get it to work right. But then you have to go and buy 6S batteries to actually make it function optimally. Sure, it works fine on 4S, works great on 5S, it works even fine on 3S, but again, this is not a beginner product. At least I don't think they even think about this thing, but I would say that it's not geared towards beginners. So you would have to go out and get an appropriate 6S battery, and the appropriate size for this is going to be about a 500 milliamp 6S battery. But do you get any actual advantage to running 6S on such a tiny platform? So overall, my testing and all this stuff, we all know that aerial photography platforms, and particularly like the big DJI stuff, some of them even run on 8S, and that's for a very specific reason, which I'll get to in a second. But in racing quads or performance quads in general, the need for 6S or higher voltage is for different reasons. The reason why you would want to run higher voltages is, number one, you're racing. So you are pulling so many amps out of that battery that it's just, the battery cannot sustain the amps. And you can increase the capacity of your battery, but it's still going to be out of balance. So the battery has voltage and amps. So these two need to be balanced in some sense for the battery to actually be able to manage it. You can't just have a massive battery and expect to draw tons and tons of amps out of it. That's out of balance. That's just inefficient. So that means you should move up in voltage and drop the kV of your motor. So the end resulting power of the quad is the same, but you just drop the amps because now you have more volts to pick up the slack to get equivalent wattage. On light, tiny, small quads, you really don't have a lot of need for higher voltage. On something like the toothpick or a toothpick class quad, like a 2.5 inch tiny thing that's super light, the difference between 2S and 3S is really not that significant. In fact, the 2S may be faster on some quads than 3S. Even 1S on a toothpick feels very similar to 2S. It really does feel very similar. So why on earth would they put out a 6S 3-inch quad other than just to get people to buy it? It really is just a wow factor for the consumer to say, wow, 6S quad, I want that. And they go out and buy it. Another reason why this product is just poorly specified. Just poorly specified, poorly designed. Some of the parts are okay, just poorly specified in general. So for this size class, I really do believe the higher kV and 4S is really totally suitable, and I really wouldn't go beyond 4S. I personally prefer 3S on 3-inch quads that are heavier like this, just because it feels a little bit different. The same way how 4S feels a little different on 5-inch than 6S does, it just feels nicer on 3S, and I don't feel limited by the amps at all, as long as you keep it to a lightweight. Keep it to around 200 grams, 3S is going to be totally fine. You don't need a huge capacity battery. So then you get to aerial photography platforms that need higher voltages for totally different reasons, sort of the same reason together. So the dilemma with aerial photography platforms is that they have to haul a lot of weight up in the air and hold it there for a while. Getting all this weight off the ground often requires a lot of power to get it off the ground, and for the same reason why racing setups in performance FPV quads require higher voltages to be sustainable easier, aerial photography platforms get a double benefit from having higher voltage. So moving up to 8S, 12S in an aerial photography platform means that your amps drop very, very, very low, and that means that you can thin out everything. You thin out your wiring, you thin out your ESC setup, you thin out all the stuff that you need. So you actually reduce the overall weight of the quad somewhat significantly, not a huge amount, because after all, it is just mainly wire, so it's not that much stuff. But the wires are a lot longer than things in our little small quads. They do have to travel along these long arms that you're running 10, 12, 15-inch props on. So their benefit is that they balance the amps and the voltages. They prefer voltage over amps and to reduce the weight. However, that's not how you get the maximum flight time. I don't know all the math behind this, but this is more just talking to a bunch of engineers and actually testing things myself. Battery capacity is what gives you more flight time, not necessarily the voltage. Yes, you can drop the amps down. However, amps running through the system, not extreme amps, just reasonable amps, seems to be more efficient than having higher voltage. So if you want to have higher flight time, you actually want to keep it to the least voltage that you need to do what you want to do. And that may not mean the maximum performance in the quad. It may mean that you have to give up a bunch of performance just to reduce your voltage so that you can increase your capacity. But with a massive capacity, now you can draw a lot more power over a longer period of time. So you want to sip the power, and the battery will never drop voltage prematurely, which is often what we are doing in FPV quads. We're just pushing the gas, pushing it hard, trying to go fast, and the battery voltage sags and drops. And a lot of the times you'll land and the battery will recover to 3.8 volts, which is above resting voltage. So that means you've landed prematurely, and you should probably have a higher capacity pack to help manage the amps a little bit better. So these are three kind of scenarios as to where flight time and voltage and performance and everything comes into play. In my personal preference for something like a long-range quad, I would still gear the quad towards performance rather than flight time, because at the end of the day it is FPV and I want to fly performance. I'm not going to like fly a Phantom 5 miles away just to float around 5 miles away. There's kind of no point to that. So I would prefer the performance, and really you can get away with just about 5 or 6 minutes flight time, and that's really the target for long-range pilots as well. They really don't need 20 minutes of flight time. They're okay with 5, 6, 7 minutes is great. There are some people that do extreme long-range flights, and they are experimenting with 18650 packs, and they're getting 25-30 minutes of flight time on a 5-inch quad, which is mind-blowing. So super mind-blowing. But they're also giving up some performance to do that. You can't race your way all the way to the top of that mountain and then dive down that mountain and race your way down the hill. So yeah, let's leave it at that. I think this is a nice long discussion as it is. Floss your teeth because that's always good, and take care. Bye. Literally the most awful quad ever. Just I just can't understand. For the life of me, I can't understand. If they chose random parts to throw together, it would have been better.